So in the previous video, we looked at how to multiply and divide algebraic fractions. It's only suitable that our third and final type is to look at what happens if you want to add or subtract algebraic fractions. So I've got three examples over here from example 11 that kind of covers the different types within this sort of third type of algebraic fractions that you'll be asked to simplify. So let's jump straight into the first one. So for part A, let's just zoom in a little bit more. So we have a 3x minus 2 all over 5 plus an x minus 4 over 4. Okay, so when you want to simplify these fractions, you generally want to get a common denominator. So the way that it's going to work, and I might just do the long way of sort of the long working out, showing all the key steps. And then for parts B and C, I might sort of trim that down a little bit to show you just how you would set it out in an exam. So for this particular one, you look at your denominator and you go, well, what is my common denominator? In this case, I can see it's going to be 20, right? So that means we have to get a common denominator of 20 for both of them. And then things will change. So originally, I'm going to get my highlighter out here. Originally, I had a 5 on the bottom of the fraction, but I needed to turn into 20. So what did I do to the 5 that will give me a 20? I've multiplied that 5 by a factor of 4. Now what you do to the bottom, you're going to do it to the top as well. So I'm going to multiply 4 to sort of the numerator of that first fraction. Now essentially what that will look like in terms of your working out is you're going to have 4 lots of your 3x minus 2. I'm going to zoom in so it's a bit easier for me to write as well. So basically what we did to the bottom of the fraction with the 5 is we multiplied it by 4. Just make sure you do the same thing for the numerator. And you can have 4 lots of, I guess in this case, brackets 3x minus 2. Now I'm just going to rub that out and rewrite that nicely because it didn't look as nice as I wanted it to. So it'll be 3x minus 2. That's a bit better. Now we're going to do exactly the same thing for the other side, right? So the other side has a denominator of 4. Need to turn it into a 20. So what did I do to the 4 to get to a 20? You multiply that by 5. So you're going to do the same thing. You're going to multiply 5 to the numerator of the second fraction, lots of what was originally there, which is the x minus 4. All right, so now that we've got a common denominator, we can essentially write down the same fraction, sort of one fraction with the same denominator. So it's going to be all over 20. And then we're going to essentially have a 3x minus 2 plus a 5x minus 4. And I might extend that a little bit longer there. All right. Expand looks like it's our next step. All right, so when we expand, we get a 12x minus an 8 plus a 5x minus a 20 all over a 20. And then you collect your like terms and you're going to finish. So it's going to go equals, I've got a 12x and a 5x, so that will give me a 17x. And minus 8 minus 20 would be minus 28 all over 20. Okay? Now it's at this point here that I'm looking at it and go, can I further simplify it? How do we go about sort of doing that if we can further simplify? You look to see if you can factorize things and cross things out just like it was in the previous two types of examples, where you would factorize and you cross factors out. But the 17, the 28, the 20, there's nothing I can factorize there. So this will be essentially my most simplified answer. And I'm gonna leave that as my answer. All right, so with these ones over here, I guess the only difference is you want to go ahead and you want to combine the two denominators, combine the two fractions by getting a common denominator first. Maybe you'll have to expand, that is quite typical, collect your like terms, and then just have a last look to see if you can further factorize anything to cross things out to get a much more simpler answer, which generally doesn't happen, to be honest. All right, part B, let's have a look at this one over here. So in part B, we've got a 3 over x minus 2. Now for this one over here, I'm not going to do every line of working out just like I did in the first part, in part 8 over there, particularly that second line here. So I'm referring to this part over here where I generally go from the original question straight to that third step because you can see it's not a dramatic difference between those two lines of working out. So I'm going to go ahead and do that for parts B and C, and I'll show you exactly what that thought process is to get to that stage. All right, So once again, we need to go ahead and get a common denominator. Now, the difference with this one here is that we have algebraic terms on the denominators. And that's not a big deal. That just means that your common denominator would be each of those factors. So we have one large fraction. So remember, we're combining these two fractions together. And instead of writing two separate fractions, I'm just going to write down one whole fraction with a common denominator with each of those factors listed there. All right. However, this is where you have to be a little bit careful. You have to change the numerators. The numerators will change accordingly because you've changed the denominators. So what I mean by that is that originally my denominator was an x minus 2, but I've turned it into an x minus 2x plus 3. So what did I do to the x minus 2 to give me this sort of new denominator? I basically multiplied by an additional x plus 3. So the way that would work out with the without working out, I suppose, would be the 3 for the first fraction was already there, but I had to multiply by an additional x plus 3 in order to get that new denominator. Now, the same thing is going to happen with the second fraction. Originally, it's an x plus 3, but then it's going to look like x minus 2x plus 3. So that means I would have multiplied by an additional x minus 2 factor. So let's get rid of all of these highlighted markings. So we have originally a minus 2, but then we have, we need to multiply that by an additional x minus 2 factor. All right. So that is our first step. We've combined the two fractions together with the same common denominator. And this step here is essentially kind of like our part A, but going straight to that step. Okay. Now, if you need to do that intermediate step just for the first few questions until you guys get the hang of it, by all means do so. But you always want to strive for basically trying to get to this step here as your next line of working out. Because when you do, we sort of see the light at the end of the tunnel, right? So at the bottom of the fraction, I'm not going to do anything to that. So that stays the same. The numerator always, like I said, you're going to be expanding a lot of these things out and then collecting your like terms. So when I expand, I'm going to get a 3x plus 3 minus 2x plus 4. And then you collect your like terms. Let's move down a little. So we're going to have a x plus 7, because 3 plus 4 is 7, all over an x minus 2 factor with an x plus 3 on the bottom there as well. Okay, I can't cross anything out because none of those factors are the same. That's my simplified fraction for this problem here. All right, we've got a third and final one for part C. So let's just zoom in here if my tablet lets me. So for part C, we've got 1 over x minus 4 all squared. And we're subtracting that with an x plus 1, x minus 4. Okay, so this is kind of like a similar question to part B where we had a algebraic denominator. And it's okay because in this particular question here, it kind of looks like both denominators are x minus 4. It's just that we have an x minus 4 squared. So when you have a situation like that, your common denominator is going to be that x minus 4, but you're going to take its highest power because you've got x minus 4 squared of them. So the thing that will be common would be x minus 4 all squared. So always take the highest power when you have the same algebraic terms. Now, with that being said, that first numerator doesn't change. So it was originally a 1. It remains a 1. And it remains a 1 because the denominator really hasn't changed to x minus 4 all squared, right? So if it doesn't change, the numerator doesn't change. It stays exactly as it is. On the other hand, though, so we have a minus, and then I guess we have an x plus 1 for the time being for the second fraction. And what we have over here is we need to multiply that by an additional x minus 4 factor. Because originally we had an x minus 4, but we need to get to an x minus 4 squared. So we have to multiply that extra x minus 4 factor there. And it was already an x plus 1 there, so you need to write the x plus 1 there before it. Okay, so let's move on to the next line of working out, which is just all about expanding and simplifying, collecting your like terms. So you can see we're not going to do much to the 1, but we are going to go ahead and expand that second half there. So when we expand that using our normal distributive laws, it will be x squared minus 4x plus an x minus a 4 all over x minus 4 all squared. Okay. Continue to simplify, right? So let's go x minus 4 all squared on the denominator. Now on the top here, we're going to expand that negative out there, right? So this x squared is going to actually turn out to be negative x squared. This minus and the minus 4x here would be positive 4x, but there's actually more going on than that, isn't there? Because they're like terms. So if you have negative 4x and you're plussing an x, you're going to have negative 3x, but there's a minus in the front there. So it'll just be positive 3x. So let's just get rid of that and go positive 3x. Lastly, we have a negative 4 at the very end there, but when you expand it with the negative, it's going to be a positive 4. So 1 plus 4 here would be 5. All right. Now, if that was a little bit too much, by all means do an additional step and expand the minus into the long brackets there and then collect your like terms. But you ultimately want to be able to get to the stage where you can just visualize and pinpoint these things, particularly because we're in year 11 now, we want to be a little bit more efficient. All right. The numerator there, I don't think that factorizes. So that means there's not much more we can do to it. The bottom's already in x minus 4 all squared. It's nice and perfectly factorized. There's actually no need to expand these denominators out, right? So for each of those ones there, if you were wondering whether or not, so for parts B and part C, the denominators, should I factorize them? Generally speaking, there's absolutely no need. In fact, it's better that it's factorized rather than expanded. All right. So with that being said, so these are basically your sort of third type of algebraic fractions to go ahead and simplify. And it's all about combining the two fractions. There's a bit of expanding in the middle, and then towards the end, you're going to collect your like terms and then see if things will further cancel out or just collect your like terms. Hey everybody, if this video helped you, make sure you subscribe to the channel. It supports the channel and helps me keep making more free content for you. I'll see you guys next time.